You can see they are seating in a right order. So a quick introduction. Bob Wiederhole is CEO for Couchbase. Shekhar Iyer, he's the SVP for Global Field Operations. Ravi leads products and engineering. He's the Senior Vice President for that. And Peter Finter is our Chief Marketing Officer. I just want to explain that the questions I have prepared, I lead the developer advocate effort. I talk to a lot of our customers, partners. So none of the execs, rather not very many people, maybe a couple of people at Couchbase know these questions are. So they don't know what the questions are, okay? So it's completely new question. Well, they probably know the answers, I hope so. But the questions they certainly don't know. So as you are listening, hopefully we are addressing your concerns here. And if you have any questions, I would say start writing them down because you will get an opportunity. All right, so what I'm going to do is, just to kind of get the discussion going, my first question is actually going to be to Bob. So I will address a question to one particular panelist, and then other panelists are welcome to kind of jump in. So Bob, here you go. One of the reasons our enterprises move to NoSQL database is the ability to handle unexpected spikes and growth for their applications. That's sort of the reason that we've seen. Can you give us some concrete examples on how Couchbase helps customers manage that?
Well, so certainly in different of the digital economy verticals, you get those spikes for different reasons. Certainly in e-commerce, you have Black Friday, and that's one of the major spikes. Apple is one of our customers, and they get huge spikes when they announce a new phone is going to be available at 10 o'clock on, Saturday morning or whenever. So each of the different verticals have different reasons for the online sports and casino betting. For example, a lot of the online sports betting during Euro Cup, there are huge numbers of bets that are placed on various matches. So there are a lot of different reasons why people have spikes, and most of the customers, well, I guess customers deal with it in two ways. If the spikes are not too great, then we actually find a lot of customers that really just size for those spikes and leave the size of their clusters running at that size throughout the year, because they don't want to be increasing the number of nodes in their database cluster and decreasing them. They think they can make sure that they have better stability by just maintaining that number of servers throughout the year. But then when you have a very big spike, then we certainly will see customers add a fairly large number of nodes to their clusters. And obviously NoSQL in general, and I think Couchbase does a particularly good job of allowing you to elastically scale the size of your clusters very easily, using pretty much a push-button approach to add additional nodes, rebalance the data among the greater number of nodes, et cetera. So this is something that for many of our customers is kind of normal operations, and it's something that we make pretty easy. Now, one of the issues also is from just a business perspective. How many nodes do you need to purchase? Do you need to purchase, full year licenses, even though you may only use a large number of nodes during your peak periods? And we work with customers on that. We give them additional nodes to use for some number of months. Typically, if you're going through a big peak, customers will set up their larger clusters a month or so before, for example, Black Friday, and continue that through the holiday season. And so we'll make business arrangements with customers so that they can meet their needs without any significant administrative overhead. So, you guys want to?
Yeah, one specific example is the Pokemon Go example. When we started out and when we were working with them initially, they didn't know that this was going to be the biggest game in the history. They started out with literally 8 nodes, and as Bob said, we want to be flexible to our customers, and said, we realize the ability to forecast is going to be difficult. So at any point in time as you're rolling out, you will have a 30-day window to be able to assess what is the usage that's there, and we will work with a relationship to make sure that you're able to scale your business without that being an impediment. Now, within a few weeks of going live, it went from 8 nodes to 72 nodes. This is the biggest game in the history of the world. And they were able to seamlessly do it, as Bob said. And we're there to help them. And that's why they're looking at different applications to be able to scale their solution.
My turn. I won't drone on, but two things we are sensitive to is that, yes, on the upside, you want to add more capacity. But in industries like gaming and video streaming, there are spikes which are when they not on. I got to get closer to this thing. Sorry. I got to be like the Coldplay lead singer who pretty much eats the mic as part of his singing. Trying to be nice, but well. So scaling back is also a very important factor, which is also one click, so that you can reclaim the extra provisioning that you have done, which you can redeploy for other reasons once, let's say, peak happens. Games sometimes are popular and they lose popularity. There are days when video streaming has its own Black Friday, so to say, which could be multiple days based on the event they're streaming out. And so you may want to provision for that. MLB and other ones do this thing. Red Bull's another one, which all have this media streaming. So you can do it, scale up, and then scale back, and you can reclaim that capacity for other purposes. Now, the beauty of what sort of Shaker mentioned, the case of Pokemon, is that it solves a very critical problem, and you guys in your businesses know how important this one is. So assess this. When they provisioned the first 8 nodes, they came to us screaming with performance issues for query and indexing and stuff like that. The magic of adding the next 72 nodes is that the data never got resharded. This is the problem you typically have with any of the standard relational deployments, because they co-locate data and index, and the moment you create new index spans, you basically have to go reshard the data so that the indexing is redone. So in this case, they never touched the data. It was still running in those 8 nodes. It was well provisioned for that. They kept adding query and index nodes, and that's why they could take the 5 nines uptime, and they didn't have to sort of bring down their services at any point. So these are all sort of architectural things. Why you see this. This is possible only in NoSQL. Why? Because of the shared nothing architecture. Otherwise, if you were using relational systems or the previous ones, which I have built too, is that a priori you have to make a decision. What is the size going to be? And then go buy bigger and bigger hardware. Go get this Solaris box, this AIX box. Those used to be the discussion, and those were sort of capital investments you had to make upfront, not knowing what the outcome is going to be. So it's a dynamic nature of the business now. You're going in thinking that I don't know how big this success is going to be, and you can then dynamically adapt to the market conditions and invest more based on how the reception of the product or the service that you're introducing.
Since everyone's got a Pokemon Go story, I'll give you mine, which is that the planning that went into Pokemon Go, they did a fair amount of planning, and they predicted their worst case scenario, because they had dependency on their compute infrastructure that they also had to give consideration to. Their worst case scenario was 2x the demand that they anticipated. Within 100 days, it had grown by 50x beyond their worst case scenario. So the ability to respond in real time was critical to them, generating $470 million in 100 days from that game. And the ability to scale their infrastructure was a direct dependency and a result of the choices that they made to invest in a NoSQL environment. That kind of flexibility is not available, folks, from anywhere else.
So not only the product is technologically superior, but I want to give a shout out to our support team, who was fundamentally very important in making sure that they, all lift up to our promise. So absolutely. Okay, yeah, cool, very
awesome
cool.
Work.
My next question, really. Another prominent use case that we have seen is where our customers are re-platforming. They are moving from relational databases to NoSQL. And Shikhar, this is probably more a question for you. Why are they doing that? Why does it matter? Perry kind of gave that previous session on the migration aspect. Tell us some of the customers who are doing it and why are they doing it?
Sure. I think, Arun, there's really 2 fundamental reasons what I hear why customers are thinking about it is. One is, as we've been talking, the digital economy with web and mobile and IoT fundamentally needs a different architecture or a response to the requirements. So the first thing is just, there is a apples to oranges comparison between what is relational and what a NoSQL environment can do for you, and as a platform and how it solves that problem. I think the second reason is because the relational world is not as flexible, doesn't have the elasticity, but also the cost effectiveness. Because as you just saw and you heard on the Pokemon example, the ability to do that with commodity hardware, being able to do it in a way that's much more cost effective is not what's working for enterprises today. So there are a lot of companies that say just the business ease, the business flexibility, the economics of how this is done, but the primary reason is really a NoSQL platform gives you a much better way to satisfy today's architectural needs.
Maybe I'll just add a couple of things to that. You know, just a minute ago we talked about scalability within a cluster to be able to meet the peak demands of your business. But another dimension of scalability that we see coming up over and over again is the fact that most of these digital economy businesses are global businesses. They have customers all around the world. And one of the things that most of these global businesses feel like they need to do is to have data centers in multiple locations around the world. We're finding, you know, some of our bigger customers have plans for 12, 15 different data centers around the world. Maybe they only have, you know, 2 or 3 today. And so that's another dimension of scalability. You do that, obviously, so that you can reduce the latency associated with the internet. You do that for disaster recovery, or simply if one data center goes out, then you'll have other data centers that can accept the load. And so that's another dimension of scalability. For many of our customers that, for example, are running Oracle, if they're moving from 1 or 2 data centers, even to 5, let alone to 10, the cost of doing that is so ridiculously prohibitive that they have to find another solution. So that's another, you know, reason. That's not for every customer, and you know, I don't think there's one reason that people move. Another thing I'll say in terms of performance, more, you know, from the customer side, is that more and more of these digital economy businesses are measuring what the response time is for key features. And what they're finding is that the response time, as their web and mobile applications become more and more complex, as they're trying to do more and more, is these response times are increasing by very material amounts. And they know that the longer the response time, the more frustrated users get with their applications. And they actually do studies whereby they lose customers. They can directly correlate the increased response time with lower business. And so that's a kind of a dimension of performance. Now, obviously, the database isn't the only component of delivering better response times, but it's one of the key components. And so we're seeing a lot of customers that simply want to have better response times. They think that the performance of the database is a key mechanism to get those better response times. And so they just don't think they can get those with the relational technology. So I think it's, you know, it's varied depending on the customer, but there are a lot of different reasons.
Excellent. Well, Ravi, my next question is for you. I know you're a database geek. Now, the way database industry is evolving, you know, relational databases are adding support for JSON. Couchbase is a NoSQL document database. We're adding support for SQL query language over there. We have added support for full text search as well. People want analytical support and all sorts of features. Where do you see the database industry going forward? And do you see a convergence of relational and NoSQL, or do you see one versus other?
So first thing is I want to demystify one thing, which is the change is one of fundamental data model change. That's what's happening with this web and these web scale applications, because what has become is that the language, the data is transmitted, talked about, is all JSON. So that's a foundational change. Now, the relational model, when they talk about adding JSON support, what they're actually doing is putting that JSON in a column, right? So it is not a foundational architectural change. They are fitting a data type. They are providing a support for a data type. You can only go so far with that. The foundational difference here is a data model change. In one sense, it's a hierarchical data model. Now, if you really think about it, mainframes had this thing way before. But we're not going to the mainframe days, don't worry about it. But the point is that the foundational data model change is what this is about. That's why we call ourselves a document data model. JSON is a choice of the document data model because that's the most popular one. Before this, there was another document data model called XML databases. That didn't go too far because it didn't do the true data model thing. It came from the document markup language side of the equation, so it carried a lot of baggage. And the XML parsers, you guys know the story, how much time you have to spend just doing simple things. So this one is coming from the right abstraction standpoint to say that an object, if you devolve the object of all the logic, what is remaining, the data portion of it is the JSON. It's describing the data portion of an object in a JSON, and it's got implicit relationships built into it, which if you save and retrieve, you don't have to do what is called as the object relational impedance mismatch. The best way I can describe that is what Esther Dyson once said. It's basically like you driving your car to the garage and then disassembling the car part by part and storing it in the garage. That's what you're doing when you go from an object, taking an object, tearing it apart and putting it into tables and columns. And every morning you can reassemble the car part by part and then drive. But after a point you're asking the question, is that the most optimal way of doing it? That's exactly what you're doing when you take an object and try to fit it into a relational schema. Because you're taking the object and tearing it into tables and columns, creating joins where there's nothing required, and then you're reassembling it because it has got to go back to the POJO, and then you're programming to it. So that's the foundational problem that we've solved. When you use a document model or a JSON document model database, that entire impedance is gone. You're programming to that at the web tier. REST over JSON is how it is. So on the browser using that's JSON is what is transported over the wire. And if the same JSON is stored in the database and retrieved from the database, all this ORM mapping, middle tier, all that stuff is just extra processing which is not required anymore. That speeds up the application tremendously, simplifies the programming tremendously, brings agility to the development. So that's the first thing I want to demystify in this whole conversation about relational versus this. The second is in terms of where is the database of the future going to be. You are seeing it now. This is how a database has to be architected, which is basically scale up and scale out, and be able to dynamically adapt to the virtual way of deploying them in all over the place, because people will have network compute storage and they will assemble that and then they want to deploy services on it. For the first time, you can deploy a database based on those characteristics. Earlier you had to buy based on the lowest common denominator. If the bottleneck was a query or a storage or a compute, you had to go buy the whole thing new. You had to give up your car and go buy a truck. That's not how we are doing. A better example would be like an airplane. You had to go from a small Learjet to a jumbo jet. So you had to go buy the whole thing. The way we have built it is basically, it's like a train. Just add 3 more bogies and you're ready to go. More capacity, this is late binding concept. And you can basically bind more based on the capacity you really need. This is what you need in the modern world of deploying services in the virtual machine part. And that's what this database is going to do. Now, that's part of the future. The other is, what we have done is, because of the workload isolation piece of it, my apologies for not getting my baritone out. The second part of it is the ability to isolate workloads. And because of that, I can add more capacity to the same sort of a cluster. Just like you saw data index and query, next we added search. One doesn't impede the other. Just because you have a long-running query, your key value gets and sex will not be impacted, or a search will not be impacted. So we can add other capabilities to it, like analytics or a graph or any of those capabilities. So it is pre-baked architecturally to add or enable other services into it. So it will take on a lot more. It is basically it's like a smartphone. It's 40 devices into one. So a database correctly architected like this will be able to do a lot more than what we traditionally think as a database. And we have purpose-built a lot of solutions in the past. Now we are able to consolidate them all in one place. What is the advantage? Always performance. Second advantage, always price. So if you have seen ads in the 90s and you wanted to buy all those devices, which this lovely smartphone now encompasses, you'll be paying 4 times the price, even with the full price of an iPhone, because a computer alone, what it can do now, earlier would have cost you a couple of $1,000s, which the processing that this device can do. So price is always a great advantage, and by collapsing or layer consolidating, as we call it, by getting a cache and database into one, it becomes a much more efficient system to program to, and that enables other productivity across. Developers can do stuff simpler and faster, and you can get to market sooner. So that is the future, where more capabilities will be added in this platform, and you can then leverage that by having a much more simpler programming model.
Maybe I'll just reinforce a couple of points that Ravi made. I think through, symbolically at least, through the end of 2014, there was a lot of talk in the NoSQL industry about what some people call polyglot persistence, right? Which was this notion that companies were going to use many different databases, each database that was highly tuned for specific use cases. We never believed that. We really believed that that was simply a manifestation of the relatively immature new technologies. By definition, because they hadn't had enough time to evolve, they simply focused on very narrow use cases, right? And then starting in 2015, you started hearing a lot more talk about multi-mode databases, right? And we believe more in that. I don't personally like the term multi-mode, but we think that we absolutely can build a general purpose database that will meet most of your requirements for your digital economy businesses. And we want to be, from a business perspective, your preferred vendor in delivering that general purpose database for a wide set of use cases and delivering a wide set of technologies. We don't think that certainly big enterprises are going to be working with 14 different vendors, each of which has finely tuned capabilities for specific use cases. We think we can finely tune the ability of our database to support those use cases, but all in one product. And we've tried to build an architecture that will allow us to do that. If you want a very scalable, super fast key value capability, we'll deliver you this late binding that allows you to do that. If you want to run complex queries, we'll make sure that you can do that in an environment where that's highly optimized for running complex queries. So that's our view, and certainly the leaders are building these multi-mode databases. We're all looking to provide a very broad solution and not just focus on specific use cases.
Awesome. Well, Peter, I have a question for you, but I'll come back to you in a minute. How many of you would call yourselves as a developer or an architect? Half the room, I would say. So this question would be relevant. So Bob, this is either you or Ravi, you. So the trends which are popular these days, particularly in digital economy company, is cloud, containers, microservices, IoT. What makes Couchbase special that these developers and architects should care about?
Yeah, I think so. This is basically, now let's talk about IoT, mobile, and then I'll come to the cloud part of it at the end. So far, mobile has always been a problem that is solved at the application tier, and I've personally solved it in multiple other places. The issue out there basically is a lot of people say they are developing mobile applications. What they mean by that is that the application is running on your device, but the critical thing is not there. The data is still sitting behind a firewall somewhere in your server. So it's making the full round trips to get the data. The rest of the application code is most definitely here. And I use applications where I have the entered data on the phone, on the device, but just to get to that, it'll wait a few seconds, Ravi, circles, before the data will be presented to me. It happens all the time. The reason is that the data is that requires distribution. And so far, people are not building people have started to build. Some of you are pioneers in that. So the thing is about, the insight is the data has to be close to where your application logic is running. So bring the data. So when you do that, the bigger problem is what requires solving, which is conflict resolution of data. What happens to data that I enter and someone enters on the connected system? How do these collisions, which one should win? What happens if one loses? Because if it silently goes away, to you looks like a data loss or data divergence, so many issues come up. So the sync gateways that we build solves that magic of being able to synchronize the data and resolve conflicts and give you a sense of you are in control about the data, what is going, what is coming, and why. So we have solved this problem at the data tier. Many have solved this problem at the application tier. So far, historically, it has been solved at the application tier, not at the data tier. So that enables now the mobile application, and the mobile can be extended to a case of human wearable and a device kind of an interface. And it can be extended to a case of, instead of mobile being a device, mobile can be deployed as a gateway to which millions of sensors talk to. Now the beauty of this approach is that a lot of people solve this IoT problem by bringing the data, the sensor data, all the way to the cloud, which is a sheer waste of network compute and storage. Because most of the sensors, they know only one thing. They'll tell you, I'm awake, I'm up. They don't even know to tell you that I'm asleep, which means they're basically lost it, right? So they'll only tell you that they're up, and they can sense that and give you a million times a second. That is useless. The real information in that is when actually it's that data that I'm up doesn't show up. So that state change is all you need to take action to that thing. So you should be filtering this data at the edge, and only the information should be passed. I did not hear from this device for the last 3 seconds. I should have heard from this device at least 1 million times by now, but I did not. So let's take a corrective action. So that data should be filtered at the edge, and the information should be passed up to the cloud. So this you can do with the way we've architected this, where at the edge, at the gateway, you can do your filtering, because there's a database there. Now that you have a database, you can store it, you can query on it, you can filter it, and only send the information that you can. So that is how we are addressing in one platform the IoT and mobile scenarios. Now, your question was about cloud. So there are multiple ways to slice and dice this cloud, because there's a private cloud, there's a public cloud, there's a hybrid cloud, and in the cloud also, what sort of at what stage, at what tier do you provide data privacy and data partitioning? That's the question. You can do it by using containers. You can do it at the application tier by striping the data. Or you can provision individually multiple boxes in the cloud, however you want to do it. The way Couchbase is built and the way the Couchbase gets deployed, because of the sort of in production cases of the scale, it is basically offered even within large enterprises data as a service. So they're standing up private clouds. And you can, the way we have built it is to set up a private cloud as well as deploy it on the public cloud. Like you can deploy Couchbase on all the platforms. We are platform neutral, as in it can be on Amazon, it can be on Azure, or it can be on Google Compute. Now the beauty here is this, that a lot of enterprises, data is the new currency, it's the new oil. They don't want to give control of this, put it on the web, put it on the public cloud, and then no control over it. So the way we see this deployment happen is that a lot of people will keep that data, which is really private to them on premise, which is surrounded by sort of the data that can be in public cloud, which you don't, it's not that privacy related stuff is not involved there. So you can set up an XDCR, the cross data center connectivity between a public cloud and a private cloud, and you can move the data from one to the other seamlessly. So that way you can have your deployment in the private cloud environment. If you get to a service which is popular where you have to store a lot more secure information, then you can pull it back to your enterprise. Until then, you can experiment with that service on the public cloud, and you can derive the benefits of cost being lower. You can start with something which is in the public cloud and then pull it to your private cloud. All the scenarios possible the way this is built. And it now follows the paradigm of a public cloud deployment as well, which is elastic scaling. You can get, Amazon has small, medium, large kind of boxes with compute and storage of different characteristics. you can deploy Couchbase to those. And many customers, some of our leading customers actually start there and deploy there. Eventually, some of them are still continuing, and some decide to pull some of it back onto the enterprise. So that's how modern infrastructure has to be, so that you can be flexible. We don't, at this point, we adapt to the needs as opposed to the enterprises having to adapt to how a vendor actually is sort of designed.
Maybe I'll come at that just from a slightly different perspective, which is that you've just mentioned some of the biggest trends that are causing massive change underneath the digital economy infrastructures, underneath these web and mobile applications that people are building, right? So cloud, we can't be successful if we're not 100% behind supporting private cloud deployments as well as public cloud deployments. People are moving to microservices architectures, and part of the reasons that containers are so, people like that idea so much is because everyone's moving to these microservices architectures. So we have to support containers, and we're 100% in support of that, right? So you know, there's major trends that are driving huge disruption. So it's not just all about changing out your data tier. It's about a very significant change up and down the stack, up and down the architecture that underlies these digital economy businesses. And so you can count on us to, 100% support all of these trends. We have to. We're a big part of the change that's taking place.
Yeah, and if I could just add, if you look at Viber, it's purely deployed on AWS and has been for their phenomenal growth. If you look at what United is doing for their mobile app with the mobile wallet, they have their own virtualized private containers that they're going to be deploying that, and they don't want to share that information outside. And there are on-premise solutions, are banking, insurance companies, or healthcare companies, or government organizations. So we have deployed in all these different scenarios, and I think we are here to be flexible, as Ravi said, and we will work with you, and our teams are happy to engage with you and kind of figure out the right architectural deployment as you're going through the transformation.
I think to me, the key part really is these are industry-changing trends, and we are very much part of it. If you want to adopt containers, absolutely. We work 100% on all sorts of containers. You want to do cloud? Yes, absolutely, we work there. So we don't want to be disruptive to your architecture. We just want to complement your architecture and blend it right in there. So I got 2 more questions before I'll open it to the audience. Peter, question for you. Our audience, they look at us not just as a database company, I hope not. They look at us as thought leaders in NoSQL and how we can help them implement modern applications. Now, I know you're new to the Couchbase, but what are the kind of things that you're planning in terms of our website, our events, our outreach to them, so that they can look at us and get more information, more value out of us?
It's a great question, Arun, and part of being here today is about being able to create the connection, because we respect the community that is built around Couchbase, and we hope that we are bringing value to you in the community to be able to extend it beyond just yourself. The benefit of being in a community is that you can share and receive information and experiences from others. And what I hope you've got out of today is exposure to a wide range of use cases and customer environments and customer scenarios where problems have already been faced and solved that may be issues that you're facing right now. So my objective as the CMO for Couchbase is to spread the word, is to get that information out on a wider scale, and to give you access to the expertise that Couchbase has that will enable you to be successful in your business. And because we are an online company, our website is a very important component of that. And we are in the process of reviewing that to see where we can improve it and extend it to bring more value to you. But I would also say this. I recognize that for most people in this room, there are other people in your own organizations who are important to the decisions that you are trying to make. You have other people that you need to influence, people who frankly don't understand the technology like you do. And in fact, you understand those people better than we do, but we want to help you be able to present a message to your colleagues, to your coworkers, to people who are not technical, to help them understand the business value. So a big part of the work that we're going to be doing over the next few months is to create packages and materials that you can use inside your own organization to talk about not only the technical benefits of moving to a Couchbase platform, but also the business benefits, the commercial benefits, the financial benefits, because we know that you are going to want to invest and invest for your company, because the return you get on that investment is better than any other investment you could be making. I want to make sure that you feel that you are equipped and enabled to be able to have those conversations. So more to come, but looking forward to developing that relationship with you and growing this wonderful community even further and even faster than we can imagine.
Excellent. And my last question really is, Ravi, to you, and Bob, you as well. Now, database is something that you build as part of a solution. You don't change every year or every few years. You really lock in at a long term. So our customers, if they're using Couchbase today, what is the vision that you're showing them for next 3 to 5 years, that they see us not only as a thought leader, but they see the engineering talent that we got, that we're here to solve their problem?
So I think it begins by defining the problem at a slightly abstract level as far as data is concerned. So historically what has happened is that you would have data have a life cycle which is disjointed. Data would be in an operational store, and then there will be a time gap when you don't know where it is. Eventually it will show up in an operational data store. Eventually it will show up in a relational, in a warehouse. And because there is a pipeline of how the data gets used. You generally gather the data, query on it, search on it, then you go into reporting, analysis, eventually you start to do prediction and recommendation, and eventually you use that data, and now you take it onto a data lake kind of thing where you want to do complex event processing across 50 other systems in which data is actually getting into. So that's the whole life cycle of the data. We want to provide a platform that addresses that life cycle all the way up to taking it to we stop one step before becoming part of the lake. There's already lakes out there. We want to be pumping into the lake, and we are not interested in being that lake. The Hadoops and others are well equipped to take care of that. So the game that we are in is basically strict focus is on operational data, then operational analytics is what we call it, which is where you can actually find intelligence. At the end of the day, the applications will evolve to a point of being intelligent. Anywhere where you have a list which is based on some numeric ordering or alphabetic ordering, both are meaningless. When you're going to look for a person, you're not going to be searching for, oh, let me go up to R to find Ravi if there's a list of employees. You're looking for that employee because there is a context, and that context is you. And based on what you're doing, what you've done, you got to understand that, and based on that, intelligently sort that list of people that you're looking for and give you people who are most relevant to you, which could be based on people you're collaborating with, people who are doing similar stuff that you are doing, people in your department, people who have similar profiles than you or interests like you. That's the kind of intelligent applications that it'll evolve, and we want to provide a platform where you can derive intelligence in near real time. Because you could do all this stuff. One of the great advantages of Hadoop has been to go from doing your warehousing kind of stuff they would say, go take a number, come back 3 weeks later for this report. It has reduced that 3-week window to hours or a day. We believe if we build the right kind of systems, even that problem, up to a smaller extent, and many other problems where the lags are much higher, we can have a 10x improvement in that, where you can basically do the stuff in microseconds, milliseconds, and within seconds, instead of seconds, hours, and days. So that is how we evolve the databases of the future, because this problem is one of sheer data volume. You all know how the data is going to be exploding. That's one side of it. The second part of it is the scale of the user interaction, because the customer base is the whole 7 billion population. It's no longer segmented by your geography or where your reach is. The reach is the whole world. So if you have that, that's the one dimension, which is the scale of the number of users. You can say that I'm developing an internal application for the enterprise. Even that can be way more faster than what it is right now, and it can be developed way more quickly in a platform like this. So developer agility is one thing we'll always focus on, and the second would be the performance and scale. and being able to do all of these things in much shorter cycles of time and near real time. And if we evolve the databases to this level, I think this will, before the next paradigm change happens, which I don't know, maybe it's a colonization of Mars or whatever else that happens, until then you're safe.
Yeah, I'll just add a little bit to that, which is, look, we're going to continue to build a general purpose database, and there's lots of things that customers ask for that isn't a part of the current product, right? I mean, take, for example, graph technology. We have not felt that that's as high priority as, for example, text-based search or operational analytics. But we get a lot of requests for that, and we think we can deliver graph database technology as a part of our product at some point in time. So I'm not announcing graph database technology, but that's kind of a major additional chunk that would be part of a general purpose database. And there may be some very specialized graph database needs that you have, or maybe a neo-technology is the right technology for specialized needs. But we think a large number of our customers are going to want to try and get at least the basic capability that they need in a single database product. A lot of people ask for transactions, right? Cross-document transactions. And so someday in the future, that hasn't been something that we have felt has been as high a priority. And so that's something that we'll look at. I'm sure you can come up with another half a dozen things that, as a part of a true general purpose database that would meet the vast majority of your needs, are things that we would need to add over time. And all of those things we're prioritizing, but that's the general direction. We think we can deliver a database that meets the vast majority of your needs.
Excellent. Well, I think we have time for a few questions. So we have 2 runners in the room, or 1 runner in the room? Okay, 1. So if you have any questions, raise your hand and feel free to ask questions. This is your chance to interact directly. We got a question back of the room over there.
Hi, this is a question for Ravi. I'm a .NETer. We're in a Microsoft building. When are you going to start getting more .NET support out?
We have a fairly decent .NET support. We even have link integration into that. So I don't sort of explicitly talk about some of the stuff, but on the client side, we definitely have the right level of .NET support, and there are many customers who actually develop on that thing. I think also the link integration goes a long way in solving a developer's need, which is, I don't want to go start writing new SQL, right? I mean, that is, if I need to really tune something, I need to get there. But as far as I'm concerned, I'm developing at the application object level, and the rest of the magic of the database is hidden deep inside it. So we have that integration built in. And the other side of the equation is we run on Azure, so that should cover Microsoft.
Thank you.
And we have a developer advocate focused on .NET, and of course Peter's team works out on a lot of generating content. If you have any ideas on what would you like us to do, please shoot me a mail, arun@couchbase.com. We would love to see your ideas.
Yeah. He's the guy. This is the one throat to catch. Fantastic.
And I'm just told there is support for .NET Core that is coming up as well. So yes, .NET, Microsoft community in general is very near to us.
I mean, if you're shy about asking questions in English, I'm sure one song here can translate.
And we have a question over here.
Or I'll start speaking French, then you know you have a problem.
My question is how to convince users of other NoSQL databases to choose Couchbase.
Yes, that's not hard, because what we find in general is that people sometimes have drunk from another well, and they discover that the water doesn't taste as good as they hoped. They find themselves running into problems, limitations, issues, missing features and capabilities. And I think what's very important about the Couchbase proposition is that we architected this platform to deliver a general purpose database that is extensible in all of the dimensions that matter to you as a developer and in an operational context. And one of the challenges that we have in a general open source environment is that it's possible to download software and to operate at small scale and to become convinced that you've solved the problem. And then you try to put it into an operational environment, and then you find it doesn't quite live up to the promise. And so Couchbase, we anticipated that from the very beginning, and therefore we welcome users who have experienced other NoSQL environments, because we are quite confident that we can help them to make that migration to a Couchbase platform to grow and be successful into the future. So thank you for that question.
Yeah, and I have to respond to that. And let me tell you, as I reach out to various customers and prospects, the best example what I heard is when I was interviewing a salesperson from one of the competing NoSQL vendors. And we asked him, why are you joining? Said, we had a common customer where obviously a lot of customers have deployed many NoSQL vendors, right? Over the last 3-4 years, people have tried everything, and you may even say, we don't have the popularity of some of the others. But what was amazing and what was really heartwarming for me is this person said, you know, in this particular account, and I will protect the innocent, that this particular NoSQL was deployed 5 times as much as Couchbase, but they were charging and getting 5 times less than Couchbase. Because where there is value, and as Peter said, when people really put this through the mission critical paces, customers have graduated from prototyping or developing and understanding it, are seeing what really works when it's put to the test. And I think that has been repeated numerous times in so many of the hundreds of customers that I've touched.
Yeah, and you know, our 2 primary competitors are MongoDB and DataStax, right? Those are the other 2 leaders in the NoSQL space. And so let me make a few comments first with Mongo. Mongo's a document database like we are. Historically, our major strengths have been scalability and performance, right? The ease with which you can scale, the reliability at scale, performance in terms of low latency and high throughput. So those have historically been big advantages for us against Mongo. Now, we're not going to sit here and go through feature by feature. We have plenty of technical people that can take you through that. But at a high level, that's what I'll leave you with in terms of differentiation historically. But then a year ago, we delivered the SQL-compliant query language called Nickel. And where historically we have been significantly behind Mongo in terms of our developer environment, we think we've leapfrogged Mongo, right? We think that there are very important capabilities. Join's just one example where we have substantially better technology, and we now feel like we are not only on par, but we have leapfrogged Mongo even from a developer environment perspective, right? So that's our view. It's up to us to prove that to you, and to a large extent you to do your own evaluations and come to your own conclusions for your own use cases. But that's our view at a high level. Against DataStax is a column family technology, and so its use case sweet spots have historically been somewhat different than that for a document database. And DataStax scales pretty well. It's got pretty good performance in their use case sweet spots. But there's more and more overlap now between the 2 products. We go head to head with DataStax more and more often. And we think we have big advantages in terms of scalability, performance, and the developer environment against them as well, right? So, and just to leave you with one other thing is that Couchbase has kind of come out of nowhere over the last few years. We're nowhere near as well known as MongoDB and DataStax, partly because they've been around a lot longer and for a number of other reasons, right? But we're growing much faster than both of those vendors, right? We're growing more than 2 times faster than DataStax in 2015, 4 to 5 times faster than Mongo. And it's because we've been so successful in the enterprise where scalability and performance are extremely, extremely important, right? You can't run a digital economy business at significant scale and not care about scalability and performance. And so that's why we've been so strong, why we're growing so fast in this market. And again, fully recognize we have to prove that to you, but that's the way, you know, I would position it, and call on us to, you know, to prove it to you and look for that proof yourself.
All right, any other questions? Well, there you go. One more.
Hello. You didn't announce graph support then. You did announce the full text in the next release. What's the roadmap? What's the next step for Couchbase in the future?
We don't reveal roadmaps. Because then it puts me on a spot to deliver on that thing. So we very closely guard. I already gave you a sense of our roadmap about the data life cycle, and that we would want to support that full life cycle, and to a point when it goes to the data lake side of the house. So our roadmap would be to cover that spectrum. So as you can see, we are inching towards that. We have added structured and unstructured querying of the data, and we will add more to it. It's all about finding intelligence in the data. So we'll keep adding feature capabilities which allows you to unearth more insights.
All right, any more questions? Okay, I guess I'm just being pulled off. So I hope you found this conversation open, honest, and transparent. And that's what we want to be. We want to connect with you. I would like to give a big round of applause to the panelists.